We have to find the derivative of y with respect to x when y is given as sin x raised to the power of 10x plus cosine x raised to the power of secant of x. So let's begin with this particular function. So here we have our function y, which is given by sin x whole raised to the power of tangent of x plus cosine of x whole raised to the power of secant of x. Now let's label this as equation number 1. Now what we'll do, we'll take the help of logarithmic differentiation in order to take the derivative of equation number 1. So first what we have to do is rewrite each of the terms on the right hand side of equation number 1. Now here we're going to use the fact that if we have e raised to the power of natural log of a, that this is equals to a. Now if we use the same fact here, let's assume that sin x raised to the power of 10x, it's behaving like a, then we can rewrite our equation as e raised to the power of natural log of, so in place of a we will have sin x whole raised to the power of tangent of x. Now similarly for the second term we can rewrite it as e raised to the power of natural log of cosine of x whole raised to the power of secant of x. Right. Now what we can do, we'll make use of another fact that whenever we have log of a raised to the power of b, this is equivalent to b times log of a. Right. So that means we now have y given by e raised to the power, so we can bring the tangent x and multiply it to natural log of sine x. Similarly for the second term we have e raised to the power of secant of x multiplied to log of cosine of x. Right. So this is our new equation, our new function y. Now what we'll do, we'll take the derivative on both sides with respect to x. Well, derivative of y with respect to x equals to derivative with respect to x of e raised to the power of tangent of x multiplied to natural log of sine x plus derivative with respect to x of e raised to the power of secant of x multiplied to log of cosine of x. Right. Now we will use we'll find the derivative of each of the two terms. We know the derivative of the exponential function. Let's say if we have derivative with respect to x of the exponential function e raised to the power of x, that's the function itself, so we'll get the exponential function back. So similarly we have e raised to the power of tangent of x times log of sine x, so its derivative will be that same function, which will be e raised to the power of tangent of x times log of sine x. But since this is not x, so what I have to do, we have to use the chain rule. We'll have to multiply it to derivative with respect to x of tangent of x times log of sine x. Now similarly for the second term, the derivative of the exponential function will give us the function itself. So we have e raised to the power of secant of x times log of cosine of x. Now this will get multiplied to derivative with respect to x of secant of x multiplied to log of cosine of x. Right. Now we will further simplify. So we will have derivative of y with respect to x equals to e raised to the power of tangent of x multiplied to natural log of secant of x. So this will get now multiplied to, now we have to find out the derivative using the product rule because we have two functions, tangent of x and log of sine x. So let's consider tangent of x to be the first function and log of sine x to be the second function. That means our derivative will be, we'll take the first function which is tangent of x and multiply it to derivative with respect to x of our second function which is log of sine x added to log of sine x, the second function, and this will get multiplied to derivative with respect to x of our first function which is tangent of x plus e raised to the power of secant of x multiplied to log of cosine x. This will get multiplied to derivative of the product of two functions, so we'll use the product rule. So we have secant of x multiplied to derivative with respect to x of log of cosine of x plus log of cosine of x multiplied to derivative with respect to x of secant of x. Right. Which is going to give us e raised to the power of tangent of x multiplied to log of secant of x whole multiplied to tangent of x Now we have to take the derivative of the logarithmic function. So we know that derivative with respect to x of our logarithmic function log of x is given by 1 over x. So that means we have derivative of log of sine x, so that's 1 over sine x. So this will get multiplied to derivative with respect to x of sine x plus log of sine x multiplied to derivative of the tangent function. So derivative of the tangent function is the secant squared x, the secant squared function, plus e raised to the power of secant of x multiplied to log of cosine of x. So this will get multiplied to secant of x. Now we have derivative of the logarithmic function, which is log of cosine of x. So we have divided by cosine of x multiplied to derivative with respect to x of cosine of x plus log of cosine of x multiplied to derivative of the secant function, which is simply secant of x times tangent of x. Right. Now we have e raised to the power of tangent of x times log of secant of x multiplied to tangent of x divided by sine x multiplied to derivative of the sine function, that is our cosine function. So this is cosine of x plus log of sine x multiplied to secant squared x added to e raised to the power of secant of x times log of cosine x whole multiplied to secant of x divided by cosine of x times derivative of the cosine function gives us the sine function, but it will be negative sine x plus log of cosine of x multiplied to secant of x, which is, let's keep it as secant of x times tangent of x. That will now give us derivative of y with respect to x equals to e raised to the power of tangent of x, there's an x here, multiplied to log of secant of x holding multiplied to, we have cosine over sine. So cosine over sine is the cotangent function that leaves us with tangent times cotangent of function, which is simply 1, where 1 plus log of sine x multiplied to secant squared x added to e raised to the power of secant of x times natural log of cosine of x multiplied to, so we have secant of x divided by cosine of x, so this becomes negative secant squared x. Because we know the cosine function is the reciprocal of the secant function, so when it goes to the numerator it becomes secant squared x. We have a negative sign, so that will get multiplied to sine x plus log of cosine of x times secant of x times tangent of x. Now finally we can rewrite our entire derivative of y with respect to x equals to, so here we have actually converted this particular form secant of x whole raised to the power of tangent of x. So we are writing in the compressed form, so that will get multiplied to 1 plus secant squared x times natural log of sine x plus e raised to the power of secant to log of cosine of x, so that's simply cosine of x whole raised to the power of secant of x, and this will get multiplied to, so let's write down the positive term first. So we have secant of x times tangent of x times log of cosine of x minus secant squared x times sine x. So this is the value of our required derivative.